One of the most common reasons for a phylogenetic tree job in PATRIC to fail is because the genomes that are selected don't share any genes or enough genes for the service to build an alignment and generate a tree. As the service takes a while to run, it might be useful to know ahead of time if my genomes are treatable. So in this little workflow that we're going to do today, I'm going to show you some ways that you can determine how and if your genomes are treatable. So we're just going to pick a random setting of genomes. So I'm going to go into the Organisms tab, and let's just choose Yersinia, the causative agent of the Black Death. Very exciting. And this is the landing page for the Yersinia genus. And you can see that in PATRIC right now, we have 1,115 total genomes. That's too many for a tree and too many to view. So let's cut down the size a little bit. This fourth tab over is genomes. Let's click on that. And let's look here, all the 115 genomes, and we have the statistics and the information about those. If you look up here into the upper right, you can see the filters icon. So let's click on that. And I want to choose a few genomes to look at. So one good thing to look at often is complete genomes, and maybe complete genomes that were isolated from humans. That looks like a good selection, and you can see that there's different species of Yersinia that we can look at here. So if we want to create a genome group, that's one of the good things about the trees in PATRIC is that you can create genome groups, but there's another thing that we can do here. So we're going to do two things. We're going to create a genome group, and we're also going to change the orientation of this view. So first, let's do the genome group. And in this checkbox right in front of genome name, if you click on that, it'll auto-select all of those genomes. And once I make any selection, this vertical green bar in PATRIC that you can see here on the right will show me all the downstream steps that I can do with that selection. And one of those is group. So let's click on this group icon. This will open up a pop-up window where we can choose to create a new group or add genomes to an existing group. If we want to create a new group, we click on this down arrow and click new group, and then we need to name this Yersinia complete genomes is what I'll call this. And I'm going to add that group to my genome group folder. It automatically goes to that folder. I can choose to add it to different folders, but I'm just going to keep it with genome groups. When it's added, you'll see this message in your lower left corner that indicates you've added genomes to a group. Now, once I have this selection of genomes, remember this is the selection out of the more than 1,000 genomes of Yersinia, I can go here and change the orientation to look at those specific genomes. And when I do that, every tab that you see here that is dedicated to Yersinia as the genus will have the same information summarized for this group. So let's click on genomes. And now I have the whole group here of my 31 genomes. And the reason I wanted to do that is here I can see the protein families just for this group. The phylogenetic tree building algorithm that we're going to describe in another short segment later is called codon trees, and it looks for shared protein families across all the genomes that are included when someone wants to build a tree. So let's look to see if these guys share any protein families. So let's click on that, and sometimes it takes a little while to load, but that was pretty quick. So you can see here these are all my genomes. If I were to look through it, all 31 genomes, and it tells me up here in the breadcrumb that I have 31 genomes. This is a dynamic filter that changes the table that's in the center of the page. And across this group, I can see that all of the genomes, when you combine all the unique protein families that they share, they're 9,951. The tree building algorithm in PATRIC looks for protein families that are shared across these genomes. So if I click here, then, and this is under present in all families, if I click this checkbox, it's going to show me all the protein families shared across all the genomes. So it's got 2,076. That's a great number. That's a good number of of protein families that could be used to build a tree. So I'd feel pretty confident that I could move forward with this. Well, that's kind of boring to just do that. Let's get some more genomes to add. So let's go into organisms. Let's click on Yersinia again. And you can go outside. If you were going to go outside of the genus, this following these steps would be particularly important because you want to be sure that you get enough shared protein families. Let's click on genomes again. And let's look at the filters again. And this time, let's include representative and reference genomes. These are gold standard genomes that are used, that are identified by GenBank, and those are supposed to be extremely high quality genomes. So those would probably be good to include in our tree. To do that, we're going to create a genome group first, and then we click on the group icon. And this is we could add it to the other group, but let's create a new group. Yersinia reference genomes. And I'll just put the year here so I can remember later on in the future. So I've added that group. And once again, we wait for the message to tell us they've added it. Now at this point, let's check again. Let's do genomes. And then we're seeing the 16 genomes, and we want to look at the protein families here. And sometimes it takes a while to load. So we'll just wait patiently. I always try to arrange the circles so it's as mesmerizing as possible, because actually when you're waiting for something to load, it can be a little boring. So across these 16 genomes, there are 10,859 protein families. So once again, we're looking for protein families that are shared across all the genomes. To see that, click in this checkbox at the top that says present in all. And this one has 2,090. All right, so it sounds pretty good. This is treatable, and the other group seems to be treatable. They seem to have enough protein families that among them that you can build a tree with them. However, here's the problem. This is one group, and I have the separate group. How do I see those things together? Well, let's go into services. And here we can look at a tool called the Protein Family Sorter. So let's click on that. And let's add the two genome groups that we created. Now, if I click on this down arrow, it will show me the most recent groups I've created, which was the reference genomes 2019. Once I select it, I have to move it over into the selected genomes box by clicking on this arrow. And then I want to add the next one, which was the complete genomes. And let's move that over. There are two types, or actually three types of protein families that we use in PATRIC, but the codon tree algorithm that we use to build a phylogenetic tree uses the PG FAMs, which are the cross-genus families. And that's especially important when you're going outside the genus. You need to be sure that they share those things. So let's click search and let that run. And what it's doing is taking all the genomes from both groups and trying to see how, assembling all the protein families together. So now we have a total of 45 genomes, and we need to see the shared protein families. Right now there are 14,000 altogether. Do they share enough, and how many are enough? The codon tree algorithm allows you to choose between 5 and 1,000 protein families. So you should be thinking about that. So I click that, and now it's a smaller result. It's 1,816 that they all share, but still that's enough to be treatable. Now, just to show you what happens and where the failures often occur, I'm going to create one more group of genomes. So let's go into organisms and go to Yersinia. And let's go into genomes. And they're loading again. We're going to click the filters button again. And this time we're going to get the plasmid genomes that are associated with the genus Yersinia. So I click on those, and oh, look, some of these have very few genes. Let's get some fat plasmids, ones that have a lot of genes called on them. So I clicked once on this column head, which will sort all the genomes in the selection from lowest to highest number of coding sequences or genes. Let's click on it a second time, and then I can see there's some fat genomes here. I don't want to shame any of the Yersinia plasmids. Let's just say they have a pleasing number of genes called. So I click that first one, and I can do a shift click to select all the ones between them. And so I have a certain number of genomes selected, and I'm going to add those I'm going to create a new group, and I'm going to call it Yersinia Plasmids 2019, and add that. Now this is the reason why most tree jobs fail in PATRIC, because there is a selection that often includes a plasmid. So let's go into the protein family sorter, and let's add the three groups, the plasmids, and there they are. You have to remember to click the little arrow button, the reference genomes, and there they are, and the complete genomes, and there they are. So I've got the plasmid, the reference genomes, and the complete genomes. Let's search for those. Start the tool searching. This time last time it was 45 genomes, now it's 62 genomes, and there are 14,519 protein families. Remember, we need protein families that are shared across all the genomes, all 62 genomes in the selection. When I bring in these three groups, let's see how many protein families are shared. So under present in all families, let's click on this. And look, we're down to one protein family that's shared across all those genomes. If you include that in the tree, this tree will fail. It will not be able to generate a tree based on just one protein family. This is an important first step that you should use before you build a tree, because these trees can take a long time to build, and you don't want to waste your time waiting for something that's bound for failure. And That's all we have for today.